Today we're making Pong. This is a classic game that is pretty straightforward, one of the simplest game mechanics you can think of, and it's much like air hockey. So pretty straightforward. You got two paddles and the ball. The ball starts from the middle and goes either up or down, bounces off the walls, and you can control your own paddle, of course, by dragging, and the computer paddle attempts to follow the X position of the ball. When it goes past the top or the bottom, you score a point. Okay, let's get started with Pong. Alright, our new game scene project, Pong. In our scene editor, the only things we're really going to need are two labels to show the score. So pop in some label nodes. Let's make this one look nice. Alright, make it bigger and more clear. Cool, and let's call it computer score. And let's copy this guy. And let's name him player score. These names will be referenced in our game scene. The only reason I'm using these in the scene editor is so we can nicely visualize where they're going to be. The other assets we could use in the editor, but I found it easier to do that in code because we're going to be dealing with a lot of different properties and collision bit masks and stuff. Let's name this one the computer score opponent score. And we're going to pop over to the game scene and reference those in the game scene. Now I'm going to do a fresh slate game scene using a code snippet of mine. And by the way, throughout the tutorial, there's going to be a lot of code snippets that I use a lot, and so please pause the video and write them down, put them in for yourself. They are very useful. So here is my fresh slate game scene. We are only going to be using touches began, touches moved, and not those. We'll put in simulate. Never mind. Okay, so let's make some global variables that reference those labels we just made. So, score label, player, and opponent label, player, opponent, and we are going to set them equal to child known with name. We have to put in the exact name that we typed, gave them in the scene, and we have to cast them as an SK label node. Do the same for the other one. Alright, and now we can manipulate those labels with our variables, and we can go ahead and set the text of one of them just to see if it works. Okay. And would you look at that, we have changed the text of our labels. Make the ball. We are going to make the ball with a new class. And one code snippet I use a lot is a node containing a circle. So write that one down. Pretty useful. Call it ball. And here's our circle property, radius property. Let's make it 15. Okay, so here's our circle. We add the circle to the node as a child. Physics body has a radius that is same radius as the circle. And we want the dynamic because it's moving around using physics. We do not want to be affected by gravity here. There's no gravity in this game. And spinning is okay. We don't want it to. Linear damping is slowing down through the air. This is slowing down its spin, so that's 0. Friction and restitution is bounciness, so we want absolute bounciness, so we give this a value of 1. Okay, we'll deal with this stuff later with the collisions. And now we're going to add our ball to the scene. Oh, let's make first, real quick, give the circle a color. Great. Now I'll add it to our game scene as a global variable. So, ball. Make the instance, or add it to the scene. Right before that, I'm going to set its position and center. That's a really common code snippet I use. This is the center of the screen. And which reminds me, I forgot to do one thing back in the game scene. We are going to change the origin point to the bottom left corner by going anchor point is set to 0, 0. And now we should see the ball appear in the middle. And there you have it, a beautiful little ball. Start the ball off by launching in a random direction. Not just any random direction. It's either going to go up or down in some random angle. It's going to have a 50-50 chance of doing that. So we need a nice random function. Make a new class, make a new file, and we're going to call it helping functions, because we're going to put a bunch of stuff in here that is going to just help us out but be kind of hidden, tucked away. And this is where we're going to put our we're going to put our random CG float. So here's a nice code snippet for you. Random CG float just takes a random CG float from a range of this low number to this higher number. Okay, and we're going to use it here in the game scene. Okay, so our first custom function will be to start the game. Alright, and don't forget to call it in did move to view. And what we're going to do is we're going to start with a 50-50 chance of doing something. Now a quick way to do that is to go if now our random number between 0 and 1 is less than 0.5. So do this, otherwise do that. So we have a 50-50 chance of doing one thing or the other. Okay, now if we kind of think backwards here, our goal is to give the ball a velocity here. And what we want to do is give the ball, we have a known velocity that we want it to go toward and a known angle. But the only way that velocity is taken is in its x and y components. So we'll deal with that in a sec. But first, let's get the angle. Let's just declare it here. Call it A. Okay, in the first case, we're going to do an upward angle. So A is going to be a random number between one angle. So in this case, it's going to be going upward, and it's going to go between 45 degrees and 135 degrees. So if we're thinking in radians, we have to go cgfloat.pi divided by times 1/4 and pi times 3/4, because we have to do things in radians. Okay, so that's going in the upward direction. In the other case, it's going in a downward direction, so you can just simply negativify those, and it will be going kind of a mirror reflection downward. Okay, we're going to use that angle to get our velocity. So physics body velocity. Okay, so as you can see, we only need it only wants an X component and a Y component. So how do we get those? Well, a quick little trigonomic trick you can think about is, and let's go over to the drawing board. Okay. Alright. If you have the ball and it is going in some direction, so it's going in this direction. So that direction to the computer is represented by this angle right here. And what we need to get is this length and this length as if it were a right triangle. So we want to get the vertical component and the horizontal component of this right triangle, and we know the hypotenuse. So the hypotenuse is kind of like the velocity. Alright, your trigonomic shorthand for this is to get this x component, you just go v times the cosine of the angle, so that's going to be this angle, and your vertical component is always v times sine angle. And that's how we're going to get those two components. Alright, so what is that big V we want to do? Let's just start off with 500. 400. Okay, we want to get dx by going V times cosine of A, and the y is V times sine of the A angle. And now with our ball, we can just plug in those dx and dy. I'm sure you could make a function for this, so I challenge you to do that. Okay, so now when we run it, hopefully the ball will either be going up or down in some random angle in these ranges. And would you look at that? Very cool. And if we run it again, see if it does anything different. And there he goes. Now it's going down within that range we gave. So we know it's working. Awesome. Okay, let's make a paddle. Here's a handy code snippet for you. A SK node with a rectangle as a property. Oh, that was so easy. And seriously, guys, it takes forever to write all this. So, yeah, if you're using this a lot in games, you really got to get those code snippets. Got a rectangle. Let's make it. Oh man, how about 200 by 40. Alright, and this is a nice color. Okay, and its physics body matches its size. Okay, the paddle's dynamic is false because we don't want it to move around when it contacts with the ball. We're going to move it by setting its position every frame, so this will be false, even though it is moving around later. No gravity. No rotation. Not that that matters. And we are going to use these because it will be affected with the ball. Okay, let's make some paddles. Instances of paddles. We got two paddles. We got the player paddle. We got the opponent paddle. We're gonna set those paddles on the screen. Okay, the player's paddle is gonna be in the center of the X part of the screen and up 200. The opponent is going to be similar. But let's make it 200 from the top of the screen. Great. And let's go ahead and give the opponent's paddle a different color by accessing its rectangle fill color. Okay, color. I'm just gonna copy this little guy. And we can just kind of mess with these colors right here. So by the way, UI color with arguments red, green, and blue take a value between 0 and 1. So that's why if you're thinking in terms of 255, like one usually does with colors, you can just simply go each number divided by 255. Okay, cool. Look at those nice paddles. Oh, I can't even control them yet. Oh, that's a shame. But lovely colors. Oh man, we need to get the pink one. We need the player to have the pink one, because it's the dull gray one. That's more of a computer color. We are full of life as the human. Okay, let's move it around. We're gonna move the paddle around with our finger, and thus we begin the adventures inside of Did Simulate Physics. This is happening each and every frame. Nope, I lied. We could do it in here, but we're actually going to do it in here because this is where we have the location of the touch. So we're going to do it in touches moved with one single line. Oh, check that out. How cool is that? That was easy. Oh, look, I'm controlling it. Oh, cool. Okay, before we get the ball to bounce off the paddles, we're going to get the ball to bounce off of the walls. These are fake walls. Now, we could do real walls, but I found that this is way easier to do it like this, and you get the same result. So we're just trying to check if it's trying to go off the screen, and if it does, oh wait, so if it's gonna go off to the left or it's gonna go off to the right, greater than size width. Okay. Oops. Okay, so then we're just gonna do this action to our velocity, x component of velocity, times it by -1. Woo! Bounce. Okay, now it's time for paddles collision. This is going to get a little involved because we are going to employ the physics contact delegate. Oh yeah. We have to always do this. Set the contact delegate equal to self. Okay. Now in the top level scope above your class, we are going to... Oh, code snippet, write that down. Okay. This is going to hold some numbers to give collision bodies a number so things can tell what they are when they collide. Okay. So name this ball and paddle. That's all we need. Capital. Okay. Now what this is doing is converting it into a special number that, I don't know, it's weird. But all you gotta know is that this last number is sequential. So 0, 1, 2, 3, etc. And we're gonna reference these guys right here. Okay. Let's organize our files. I like to put the things we're not really using on the bottom. Do that. Okay, with our ball. What? If you don't save a file, it will not see it in another file. Alright. Okay, the ball's category bitmask is ball. The thing it's colliding into is paddle, and the thing that it is detecting contact with is paddle. Okay, I'm just going to copy this over to the paddle. Okay, now we are going to, except everything's the opposite. Great. Okay. And the way I like to organize in the game scene my functions is the factory built-in functions first, and then all of my custom things that I made last. So I'm going to put the contact right here. Did begin contact. There you go. Okay. So go ahead and just print something in here to make sure it's working when the ball hits the paddle. Oh, no, it will do this if anything collides with anything. In this case, the only thing is the ball with the paddle. Ah. Look at that. Oh, something. Ha ha. Okay, go into helping functions. One function that I made that really helps things out with collisions is this. So it's an extension of game scene, and what it does is it takes in two bit masks. So this bit mask and that bit mask, and there's two kinds of contacts. One where we don't need the instance of the body colliding, and one where we do. In this case we do, because we're going to do different things for each paddle. But in this one, where we do need the instance, we're going to get a callback. Yeah, this basically sorts out for the computer what is what. And when we use it, we're gonna. I'll show you. All right. So in did begin contact. Okay. All right. So contact between two instances. Okay. So pass in the contact given from here. This is where our 2-bit masks are gonna be in. So the ball and the paddle. Okay, so just hit enter and you'll get this completion. Okay, this is where you can call your two instances, whatever you want, but they'll come back as an SK node, so we have to cast them later. I tried my best, guys. It's not perfect. Okay, and this is where we execute what we want to happen. If and only if the two bodies colliding are this body and this body. Got it? Yeah, okay. So we're going to make paddle a B. So we're casting node 2 as the paddle. This is because this is the second. It turns the second thing here into this second thing here. Okay, great. Now, if I wanted to make just a very basic game where the ball just here, let me show you. If I just want to make a basic game where the ball just bounces off at the same angle just as it does any wall, that wouldn't be a very fun game because the ball would be bouncing at the same exact angle the whole time, and that's not very fun. So what a lot of games do, such as that game Break Block, you have some control over where the ball goes depending on where the ball hits on the paddle. So it depends on how far away the ball is from the center of the paddle. That gets a little tricky, but we're gonna do it. So hold on to your horses. And then after that, we'll give the computer some intelligence here. Okay, you know what? Let's give the computer some intelligence now. And then we'll do the tricky angles a little later. Okay, some artificial intelligence. So what we're going to do is make the paddle's X position follow the ball's position, sort of. Okay. So what we want to do is, and there's a bunch of ways you can do this. I want to give the paddle a maximum speed that it can't go past. Okay, so I'm going to name that maximum speed skill level, because the higher that speed is, the higher the skill level is. So let's call it skill level. And if you set it to 5, then that will be like the paddle can only go 5 pixels per frame as a speed. So we're just going to check if the ball is to the right or the left of our paddle. Opponent's paddle. Okay. If it's to the right, then we're going to scooch it to the right. And same thing on the left. Scooch it to the left. Alright. Now let's see if she is intelligently following the ball. Oh, look at that. Look at that. But can I ever win against this computer? Yeah, because, I mean, if the ball were going faster... Oh, it's stuck. It is stuck. Uh-oh. Yeah. Alright. So I think to get the ball unstuck, we have to scoot it over a little bit. So if it hits the left wall, we just have to scoot it to the right a little bit. No big deal. Okay, and same thing on the left. See, this is thinking like a programmer here. Alright. Okay, to get the ball angle, here's what we need to do. Alright, so let's say this is the paddle right here. Very lovely, awkward shaped paddle. If the ball, okay, hits from the middle of the paddle, it doesn't matter from where, if it hits here, we want it to shoot straight up. If it hits the side, okay, we want it to veer off to the left at some angle. And if it hits the right edge, we want it to veer off to the right at that same but opposite angle. And then in here is everywhere in between. So this is going to give the player some control, much like in the classic game air hockey, which is kind of what this is turning into. Now, this does not depend on what the ball was doing before it hit. So let's say the ball comes in flying at this angle, hits here. We still want it to fly off at this angle. Okay, no matter what angle it had before. Ching, fly it. Okay, go here from here. The only thing we want to preserve, however, is the speed. So the linear speed as is coming in, and we want to preserve that as is going out. And actually, we want to make it go a little faster, because that's just a game dynamic. You know, as the game progresses, we want it to get more and more difficult. It makes it more fun. So we'll do all that in the same sort of step here. Okay, first we want to get the width of the paddle. Let's call it W. Okay, because what we really want is the point, the rightmost point. Okay, yeah, let's go back. What we want to find is, so here's the ball. We want to find the distance between ball and the rightmost point of the paddle. So this distance will give us our angle. We're basically going to map this range to this range. Kind of like a map in JavaScript, but unfortunately in Swift there's not really a good map function, so we'll have to kind of do things on our own. So we have the paddle width, and now let's get the rightmost point right of paddle. And that is going to be its position, x position, plus half of its width. Okay, that distance we were just talking about is, let's call it dist, will be right of paddle minus the ball's x position. Okay, we have that. Now we want to define our minimum angle and our maximum angle. Okay. Now this is going to be from the bottom paddle, because from the top paddle we want that same angle range, but opposite or negative of those angles, and we'll do that in a sec. All right, min angle, and thinking in radians, let's do 1/6 and 5/6. So you can see how those two angles are kind of mirror reflections of each other. 5/6. Because a full pi would be half a circle, and this would be, yeah, you get it. Okay. So now we want to get the linear speed of the ball, but all we really have are the x and y components. So I made a little function for that, of course, because that is a very common thing. Angles, gotta love it. Okay, this function called linear speed takes in an x and y component and basically gives you the long side of the right triangle, basically, which is the linear speed. Okay. So let's call that v. And then we are going to use the ball's physics body, velocity x, and y. Okay. And you have to exclamation point them. Alright. So here's where we're going to distinguish between the player paddle and the opponent paddle. Let's go ahead and give them names. In did move to view, we're going to define its name. We'll do that first step. Okay, name this one player, and name the opponent's opponent. Clean it up. Okay, so now we're going to ask if that paddle's name is one or the other. opponent. What are you yelling at me for? Hello? Go ahead and fix those issues, because Swift is special. Look at all those warnings. Wow. Alright, this is where we get our angle, finally. Alright. The actual angle that it flies off from the paddle. Alright, so it's always going to start from the minimum angle plus something. And that will be the difference in the minimum angle and the maximum angle. Okay. Okay, times some proportion. Okay. Yeah. JavaScript has a really good map function. Maybe Swift does too, that I don't know about. So if it does, let me know. Because we're basically just mapping two ranges, one onto the other, if you're familiar with JavaScript. Okay, so the proportion will be, so that distance over the entire paddle width. Okay, let's use that angle in this very same way that we did in the beginning by using sine and cosine. So here, remember, we have our linear speed. We're going to reuse that speed and use sine and cosine for the x and y. If there's a more efficient way to do this, somebody please let me know, and you will be awesome. Because I don't know, this seems kind of like a long way to do this, because we're here we're converting it, we're using sine and cosine here, and we're doing it again here. So maybe there's a better mathematicians out there. Okay, and now we do the same thing for the opponent, except the angles will be minus, or the negative versions of those angles. Easy. Okay. And cross your fingers and hope that it works. Whoa, that was weird. Ooh, that was cool. We can totally fix that in a second, but yes. Alright, let's hit it from the side. Oh, look at that. So hit it from the right side of the paddle, or the left side, it goes off left. Hit it from the right side, goes off to the right. And if you hit it in the middle, it goes kind of straight. It's pretty cool. But remember that glitchy thing that happened? The kind of got caught in there? Well, that's because it's doing that angle, no matter how it hits the paddle. So we can kind of put a constraint on it, saying that this can only happen if the ball is at a certain height away from the paddle. So only if it is greater than, then the paddle's position plus, and we're just gonna say 20 because we know that the ball has a radius of 20. All right, pop that in there. All right, and then for the opponent's paddle, of course, it'll be if the y position is less than the paddle's position minus 20. brackets look... brackets! Okay. That's gonna be great. It's gonna be awesome. Just for fun, let's... Okay, for the skill level, I would like to make the skill level global. Because we want to change that periodically. Okay. And it's going to start off a little more difficult here. How do you quit an app in the simulator? How do you do it? Is it Q? Can you just do quit? No, that's quitting the simulator. How do you... The only thing left to do now is to make it a game. So we're gonna give it some scores to display and then get a game flow going. By game flow, I mean the different step phases of the game. So getting ready, well, game over, all that stuff. So for that, I always use phases, game phase. Alright, I always use an enum called game phase. And an enum simply just holds some words that you can reference. Alright, so we can be in the ready phase, the in play phase, and the game over phase. And that's important so that the... Okay, let's start the phase off with... So we're going to declare phase and just start it off by declaring it as game phase.ready. This is probably all because I accidentally restarted the simulator phone. It is freaking out. Okay. Alright. Okay. If the game is ready and you click, tap, whoops, you want to change that phase to the in play mode, and that's when we start the game. And now we want to get out of this method before it's too late, because we don't want to keep the code going to do this and check then if we are in the... But you know, we actually didn't need that at all. So now if you click or you tap while in the game over phase, it's going to go back to the ready phase and it'll be ready for you. Here we're going to call a method called reset game. Put it here before start game. Put things in order. Order in which they happen. Rest a game. Oh, that's so nice. Ba ba ti tu da 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 da. Okay. In Did Simulate Physics, because this happens every frame, it is important to... What we do need is to be able to score a point. Cool, cool, cool. Alright. Scoring. Alright, let's go ahead and make our score properties. Yeah. Da, 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 da. Da, 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 da. All right. Okay, go down to reset game. We are going to set the score labels to whatever the score is. So go ahead and interpolate that in that string there. Same thing with the opponent label. Which I aptly named opponent score, of course. So when we start the game, this will be set to 0 and 0, of course. Run it. Alright, now we can score for real. And we're just going to check if the ball is going off the screen, the bottom or the top. Cool, 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 cool. Oh yeah, because we never called reset game. Yeah, we want to do that in the beginning. So go ahead and call a reset game when the app starts. Then when you press ready, it'll restart the. So when you reset the game, we want to reset a couple things. The ball's position will be in the center of the screen. Okay. The ball's velocity will be 0, 0. And let's go ahead and reset the paddle of the opponent to the middle. Very good. What's the problem? Okay, anyway. Alright, scoring for really gonna score this time. Alright. This is when it scores on you. When you lose a point. Oh my god. Score. Okay. Yeah, we're actually not. A lot of times we have a method called game over. In this game, we are just gonna set the game phase to game over because we don't really need to do anything. Alright. Okay, copy that for checking if the ball is above the size.height, in which case you get a point. Very good. Okay, so I think we should have a pretty solid game flow going on. I like to put in comments. Bounce off the walls. Computer intelligence. Whatever. Oh, so glitchy. Yeah, there's a better way to do that. Start over. You scored 55 points. Why did the computer score 55 points? I'll tell you why. Because every single frame that the ball was down there, it was his score was incrementing by 1. Oh, look how glitchy he looks. Oh, it's so sad. He is so sad. Oh yeah, we can fix that. I was right. So we only want to do this if the phase is in play. Then, when the phase gets reset, this will not happen. Alright, great. And he scored a point. Yeah, but you know what? I want this to show as soon as the point is scored. So guess what? We are going to go like this. Copy this line into this line. Okay. And really, we don't need to do this every time we reset the game. We just need to do that once in the beginning. Okay. Yeah, make it look nice. Make it look nice. Alright, okay, so the way we're going to make the computer less glitchy is basically by having it follow the exact Y position. The reason why it's doing that is because it's overshooting how far it has to go, because each frame it's going forward by 5 or less, or backwards by 5. So we are going to change things up a bit. We need to get the distance between the ball and the paddle. Only in the X direction. So that is the distance. Alright. So this is like if the ball is further than 5 to the right of the paddle. That makes sense. Yeah. In that case, we want to go ahead and have the paddle scoot forward by its maximum of 5. Okay. And then same thing for going up to the left. All right. Copy that, and it's negative instead. Okay, now just else, and this will happen when the ball is within 5 pixels of the paddle's position. And in that case, we want to have him scoot over that same distance. So he's pretty much just following the ball's exact position in that case. So he's not going to jut around, he's going to follow the ball exactly when he's close enough. Go get rid of that other stuff. Oh, what a well-behaved paddle. How nice. And he's going to score a point. 1. He's still following the paddle. It's kind of awkward. You know what? Let's put every single thing in the did simulate physics. Let's put it inside of that condition of the phase being in play. Okay. I think this is gonna make things better. Do that. Just do it. And it's gonna behave much better. Oh, how nice. And here you could change things up with the paddle ball angle. So right now, oh, you know what? I don't even know. See how I'm kind of controlling? I'm still controlling the angle of the ball. Oh, I scored a point. And he's stopped. He's done. And ready for the next round. Look at that. Pink versus gray. Alright, so we pretty much have the game. The next couple steps is just icing on the cake. So if you want to stop now and do with it what you will, that is cool. Thank you for following along. If you want to keep going down this journey and just watch me kind of make it pretty, you can go ahead and do that. So the first thing I'm going to do, every time it bounces off the paddle, we want it to get faster and faster. That's pretty easy. So in the did begin contact, at the end of everything, we want to say it's physics velocity. And each component, we're just going to times it by 1.1. So that will slightly increase the ball speed. That's going to be fun. And what else can we do? How about every time you score a point, I think the skill level should get higher. And that'll be kind of a fun dynamic to play around with. It's kind of cool. What did we just change? Oh yeah, it's going to get faster and faster. Uh-oh, uh-oh. See, I'm making sound effects with my... oh yes, I rock. I think finally I'm just going to give the background some fancy little shapes. Totally superfluous, but I'm going to go ahead and do it anyway. Let's make a class called background shapes. And we can go ahead and start with a circle. Call it B shapes. Why not? It's a happy little circle. A thin circle. It's white on the edge. We don't need physics for this little doodad. No, not at all. And we're going to make a lovely little line using a path. Oh. And we're going to start the path off from one point and just go to the other point. Oh, and since I will be positioning this entire node in the center of the game, I'm just going to go ahead and assume that y can be 0 here, and the point that the line is going to will be all the way on the other side, to the right of the screen. And there's our path. The line will be a shape node. Using that path. And the line will look very similar to cyan. Let's not get crazy here. It'll be very similar to the circle. How about that? Let's go ahead and add that to our scene. First thing, so it's in the back. Right before we add anything else. Right here. Alright. That'll look lovely. No, it won't. It will not look lovely because, ooh. Yeah, this radius should be a lot bigger, huh? Oh no. Oh, we did not set the position of our B shapes. Center it. Oh yeah. And now we're really playing air hockey. And now let's watch how many points I can get against my own creation. Will it turn on me? Will my own creation turn on me? No. Don't you love me? Don't you care that you exist because of me? How dare you play against me like this? No! No. How could you? How could you? And that's how you make Pong.